So we have the oblique triangle, and by the way, if this also works on right triangles, but you'd be better off using the SOHCAHTOA because it's thicker than all the other business. But these are, if you're into that, remember Leah brought that up on the law of signs. It's a SSA situation when you want to use the, if that helps. This is basically you're going to use the law of signs when you don't have a matching angle side across. Okay? That looks pretty complex. It's certainly more complex than the law of signs because of all the squares. You have to really watch your order of operations. But basically, it kind of starts out with, it almost looks like, what does that look like to you? Pythagorean theorem. So that's really the derivative of it, okay? And then you have to take, and you can call any of, depending on which one you want, and we'll get into all this, which one you want, either C, B, or A, you will use the other two over here and square them. And then also notice that A and B show up here and here, okay? And then A and C, whoopsie, you gotta make that notation, and this should be what? C and B, okay? So I guess I cut and pasted and didn't fix it all. All right, so these two are the same as the ones showing up here, C and B, okay? This matches with the angle across, so that is a match. C, cosine is C. With the law of cosines, you use cosine, okay? The law of sine, you use sine. So it's important to know and to be comfortable with the language because then you'll know which to use sine and cosine. Okay, so let's try one. Solve the triangle, B equals 5, C equals 8, A equals 35. So here we go. I just want to throw up a generic triangle. There's A, little a, not given. B, not given, but little b is given. C, angle not given, but little c is 8. Okay? So that's why you see the law of signs is not going to work because we don't have a match for an angle and a side across. Okay. All right, and I'll talk about this here in a minute. All right, so you want to start with either c squared or, no, I guess we want to start with a squared because that's our only side that we don't have. Okay, so it's a squared, then we have b squared and c squared. And we also have that 2, 5, and 8 cosine of c, which is 35. Okay? Now, I don't memorize the formula. I remember how it works. Let me just tell you what gets forgotten. This gets forgotten a lot. I already said sometimes people do cosine, sine instead of cosine. And then the other thing is the order of operations. Now, when it's like this, you all know it's the first day of spring. We have spring fall. Today? Yes, today. Spring. It is spring. Okay, so honestly, you can totally throw this in the right calculator. Make sure you're in what mode? Degrees. Okay. All right. Load. Hello. See anything I'm turning none of those lights on? I know. I'm in degrees. Okay. Light. All right. I better. Yeah. Okay. So you can totally plug it all the way in like that. So 5 squared. I'm going to go ahead for 25 plus 64 minus 2 times. I'm going to be real lazy. Put those all in like that. Cosine of 35 mode degrees. There we have a squared. Okay. So a squared equals 23.467. because I'm going to use that. I'm not going to round yet. Now, I would take, how do I find a if this is a squared? So, square root, good. Of the answer, pull it down, that second negative, and there we have a. Okay? So, a is 4.844. All right? Yes, I was just going to bring it to you. All right, so that's A. All right, now, would you store that as A, please? All right, so here's A. Store, S-T-O. Okay, alpha, A is right underneath alpha. Okay, so that's my A. All right. You don't really have to go crazy storing, but it's nice. Now we know what A is. Okay, now, here's where we need to say, look at this and say, use the law of cosines for the later value, even if the law of sines is applicable. Now that we have 35 degrees and the side opposite, we could use the law of sines, right? However, we don't want to because if you use the law of sines, we're going to end up with inverse sine on B and inverse sine on C or inverse sine on C, and you don't know which one is correct. You don't know what kind of triangle it is. So if you start with the law of cosines, you finish with the law of cosines. Yes, Bree? Right, but you don't need to go there. If you have a law of sines, it's going to give you one answer. Maybe. Maybe not. You don't care. You care, but you won't have to deal with it because one of them will show up on the law of sines, and on the law of cosines, and one of them won't. So then you know that
so
you. Yes. Yes. Okay. So let me see. Let's try. Okay, we are now going to find, just because it's next in the alphabet, B squared. Okay? B squared equals, I'll write it out, A squared plus C squared, what's the rest of it? Minus 2AC cosine of B. All right, little b is 5. So this is 5 squared. Okay? A squared is in our calculator, so I'm just going to do that. C squared is 64, right? Minus 2A 8 cosine of B. All right. Now, everybody stop and look up. Please watch your order of operations. You don't have to show at me every little step, but let me just say, I'm going to show every little step right now. So we have 25. You can go ahead and add these guys together. Okay? So let's see. There's my A squared plus 64. All right. 87 point ... minus 2. Let's see. 2A times 8 is 77.5097. Okay. All right, what's next in our math? What's next? And this, sorry, this is cosine B. What should we do next to solve? Subtract the 87. So 25 minus, we're at the 87, scroll up. Okay. is negative 62. Point 467. Okay. Equals negative 77.5097 cosine of B. That's what we had left because remember we subtracted 87, as Kara said. All right, now what? Divide by negative 77. Cosine B equals, let's see, we got negative 62 divided by the negative 77, so I'm going to put my negative, and then I'm going to grab my 77, okay, and that's going to give me a positive 0.8059, and then what am I going to do with it to get the inverse cosine? I'm in degrees already. Answer 36. Points 3 degrees, 0.299. Okay. Now, all this cutting and pasting and grabbing, if that annoys you, you would probably be safe to go 5 digits. Okay? If you want to write 5 digits and be done with it, that's totally fine. Anybody have the TI-83 that you can't even scroll? Okay. So if you can't scroll and you have an 83, you're just right, like right here, instead of grabbing a 62, you do 1, 2, 3, 4, 5 digits past there. We should be safe here. Okay? For your 3 digits at the end. All right. The biggest problem in doing lots of, now, why do we got an inverse cosine? Why do we not have to consider the other angle on this one? Why do we not have to consider one? It would be way more than 180 because it's in the fourth quadrant. All students take calculus, cosine would be positive again in the fourth quadrant. That's way more than a triangle. Okay? And that's the problem. And I see what you're saying, Karina. You're like, well, how do we know we don't have 2 triangles? Okay. All right. Now we have, we don't have to do a whole nother law of cosines, do we? Because what do we got? 36.299. So how do we find that last angle C? Right. 180 minus 35 and 36.299. And then do that. So you got 36.299 plus the 35. 180, subtract that. 108.701. Oops. Okay. So a lot of there's your C, there's your A, and there's your big D. Okay, we get the degree mark. They don't really give us units, so we can't really go there. When we start the word problems, we'll have to worry about the units. But any questions on law of cosines? Yes.
So, B is 2AC and A is 2B.
Yes, it uses the same. These two are the same as these two. And usually, when I do it, I will write, instead of 25 and 64, I'll write 5 squared and 8 squared when I first write it down, because then I remember those are the numbers that go over here. Instead of writing 25 and 64, and then they're like, oh wait, I gotta have the singles over here. I just write them like that, and then change them down here.
Can you slow down a little bit?
Okay? All right. So we've got, and then C was up. Remember. Okay, so again, if you don't like all the storing, all the grabbing, 5 digits should be good. Pre-rounding. Okay? All right, next page. You ready? Everybody? All right. Okay, side, side, side. You have all the sides, no angles. 6A, 8B, C5. Okay. Alrighty then. Well, we can start anywhere we want. Bridget, start it for us. This end, law of sines, which you're going to do cosine A for the unknown. Okay, so what's the beginning look like then? 6 squared, 8 squared, or 5 squared? You look at the law of cosines. The cosine A is at the end. We got to start this end. Okay? Because otherwise it's just weird. I mean, you can think I'm going to get cosine A, but you've got to start with the beginning. Okay, no problem. Okay. Okay. A and A are the matches. Okay. All right. I'm going to let you work it. Do as much as you want to. What you all got for me? Yes. Okay. If we are really on a task at plain time, how could we check this? Add them all together. Well, we know that's going to work because that's how I found the last one. How else could you check it quicker than just running through the law of cosines? Okay. Cosine of A, I'll do B first, since I got B here. So good job, Lauren. B would be 92.866. Okay, plug that in, just leave it sit in your calculator. Sine of C, which is 38.625 over little c, which was, what was it? 5. Okay, that should be close. It won't be exact because you're rounding your angle, and then A, what was A, 48.509, and side A was 6. Okay, so if you plug in all those,
Come on.
come on, get over here. This thing's getting my nerve. All right. Alright, we're in mode degree. I'm a little obsessive about checking that. 0.866 over 8, leave it. Sine of 38.625 over 5, very close. Sine of 48.509. Okay, so there's your proof. Indeed, they are the same. Okay, rather than go through, it's so easy to make a mistake. You can catch it if you do that. All right. Any questions, concerns on the law of cosines? All right. I think we. Oh, sorry. I asked for a question and then look. That's nice. Okay. Yes, Karina. All right, yes, Lauren.
So, like, if you, like, define C, for example, if you're doing it based on, like, 180 minus, you put the 3 in versus you just go back and put the exact number in, which one would you rather do?
It doesn't matter because it won't change the 3.
If it
No.
changes it by, like, 1 decimal point, is it a big deal?
I mean, it's a big deal just because you're going to get a different answer than what I want, but I don't really think it does. I don't really think it does. So,
So would you say that just put the 3 decimal points in? Okay.
because they're rounded and then that would be rounded to 3, it should be, I don't really think it's going to be an issue.
Okay.
That's a good question. She's talking about that rounding again. We have to go back to the real answers. And on the angles, I think you should be good. Okay, Karina, what? Okay. Anybody else? This time I'll really look. Okay, so we're done. That's the law of cosines. It's just a matter. Another thing you can check is making sure, like, the smallest angle should have been which one? C, was it? Okay, and then the second one should have been A, and the largest one should have been B, which it was. So that should all fit. Do you think there'd be an instance where you wouldn't get a triangle? We already talked about we're not going to have an instance where we get 2 triangles on the law of cosines. What would have to happen for us to get no triangle on the law of cosines? Can you think of a situation where we're at this point? Because this is just like, you know, plugging in numbers. What would this have to be? Or this? Or to say, oh, that's not going to work.
Say, if the fraction warrants 53 over 80 and we're 80 over 53.
Okay, yes. Remember, these numbers in purple have to be between -1 and 1. Otherwise, they're not going to have values of inverse cosine. Good job, Mel. It would give you an error message, that's right. And then you're going to frantically, oh, you're going to do it again because you're like, I guess I made a mistake. But, you know, just be aware that that's what's going to happen. You are going to get some no triangles, and that's the problem. Is they gave you a situation that really, and it was probably from the beginning, Lauren, you probably would find it because you'd be like maybe, because we talked about the other day, like maybe this would be 1. And 6 plus 1 is not greater than 8, so there's no way this is going to be a triangle when it's all said and done. So you can kind of look at that too if you think about it.
Does it have to be greater than or equal to, or it has to be greater
Actually, oh, it has to be greater than. Has to be greater than. I was thinking over here. Can we get exactly 1 and negative 1 here? Yeah, we can. Okay. We had probably a right triangle, but you don't know it's not right. Just assume it isn't when you pull it up there. But did anybody else have a question? Okay. Let's look at a little bit of the word problems. Let's see what okay. And I'll go ahead and send you this too. Let's see, real, yep. And we'll all right. This handout is going to take us a few days, so don't worry that you're like, wait, what? Am I still recording here? Yes. All right. So let me get it out to, I just sent it to you. Let me know if you don't have it. Yes. Oh, well, now. That's not going to work. Here are right triangles, law of sines, law of cosines. Sometimes the figures are drawn, sometimes they're not. You have to draw them to figure out the situation. Eeny, meeny, miny, mo, which one shall we do together? Anybody have a preference? Okay, pick a number between 1 and 5. 3. Sold. Okay, here we go. All right, we are doing number 3. Let me just snippets so that I can do it on your sheet. All right.
This is the homework talking about the handout one.
Yes, ma'am. This is it. Okay. Got a little cut off here, but you understand those are. Okay, TA, this is T back here. TA and TB are tangents. It's really too big. All right. What's supposed to be a T? Oh, I don't know. Okay. TA and TB are tangents. All right. TA.
Yes, TA.
Oh, my God. TA is 10, already marked. And the measure of angle P is 34, already marked. Okay. Find the length of the chord AB, this is what we're looking for, to the nearest inch. Okay. So, tell me what you know about this problem that is not maybe marked. Connie.
Because it's, well,
Never mind. Yes. Yes. Because yes. BC is 10 inches.
Okay. BT is 10 inches. Why do you know that? Because you had a fabulous geometry teacher. How you know that?
oh, wait, so since the two sides are the same, if you subtract
Wait. We got to get to the two sides. Why are the two sides, TA and TB, equal in the first place? Thank you. Good job, Maria. She had geometry last year instead of skipping it. Okay, so the two tangents from an exterior point are equal. Okay, so I cut you off because you weren't going to give me what I wanted. So do you want to tell me something else, Lydia?
Sure. So you find those angles. Sides are equal. Also means that the angle.
All right, those are equal. So let's find those. Okay. All right, so 146 divided by 2 is 72. 73, wow. Scary. All right. You didn't have me in 5th grade. I can't add and subtract, right? Okay. All right, so looks like an oblique triangle to me. We are looking for this, whatever you want to call it. Okay, we'll call it A. All right, so what do we do, Lauren?
Maybe this wouldn't be easier, but also you can triangle. And then you have 17 degrees at the top. And then you can figure it out. Find out and then just
She's snorting over here. Okay, that was excellent. And remember that only the this only divides this into half with the altitude of if this is an isosceles or an equilateral. It doesn't automatically, so be careful about that. Okay, so then you're probably going to use what? Trig? Okay.
Sine 17.
And A, by the way, is right here, just in case you're wondering, well, where did A go? So what is in this? What's this, really? 1/2 of A, that's right. Okay. And so on an isosceles triangle, the altitude bisects the base, and it bisects that vertex angle up here. Okay, so she said sine of 17 equals, and you can use that if that doesn't bother you. If it bothers you, then call it something else. Call X, and then work with it. Okay? All right, was anybody thinking oblique triangle? Instead of doing the trig, like Lauren said, how would we do could we use the law of sines or law of cosines?
But
Both?
I have one side.
Well, if you have a choice between law of sines and law of cosines, you should do the law of sines. It's a lot quicker. Okay, so what would that look like?
Sine of 34 over A equals sine 73 over 10.
Okay. And that'll give you it right away, too. Okay, so both will give you the right answer. All right?